right. So let's see. Welcome, everyone. Thanks for the intro. Sam says, well, can anybody hear me? If you can hear, can you chat something in? So, yeah, I can hear. Yes, yes. All right, Sam. Sorry, man. Looks like something's on your end right here. All right. Well, good. Hey, I'm stoked you guys could make it. We're going to talk about a really cool topic today. One of my favorites. I like to move around when I do this. So, hopefully it'll be okay here. All right. Well, let's get into it. So, hey, welcome to the webinar right here. It's going to be a full hour right here. If you guys have any questions, go ahead and just type those in, okay? And I'll do my best to actually respond as soon as I can. And if for some reason I choose not to, I'll wait till the end, okay? And if there's too many questions, like I miss it, then make sure copy what you typed in, and then I'll try and answer that at the very end. And I'll stay on, at least 15 minutes, 10 minutes after we're officially done to those that actually want to kind of dialogue more, okay? Because I want you guys to get your questions answered, because that's really frustrating, on certain things, if you don't get those addressed. Okay, so here we go. So, hey, I'm going to be at the Kscope. I'm stoked. This is like one of the primo conferences in the world, especially for developers. And I'll say budding DBAs. So I'm a DBA focused person, so I'm stoked because there's more DBA focused topics this year. And I'm really happy about that. So I get to talk about a couple different things. So I want to start with this. When latches and mutexes when everything's working good, we don't even think about latches and mutexes, which are all about controlling access to Oracle internal memory structures. And when that's all working really, really well, there's like this illusion, right? There's an illusion that a bunch of processes are not only accessing, but like changing the same pieces of memory, right? And that's not true, okay? But if things happen really fast, like they should, this illusion that, hey, everybody's just changing everything, everybody's getting along, no problems, all of that is it's just a giant illusion. But the reality of the situation is that Oracle has got to maintain like full on 100% control when it comes to changing the little pieces of memory, the memory structures deep within Oracle. And if for some reason that there's contention, processes can't get access to the memory structures for whatever reason, we're likely to see where that's likely to show up in the wait interface. And just to kind of give you an example here, if this is like all the CPU power, let's say, that a box has, okay, what's going to happen is as processes try to acquire these control structures to access the memory structures, we're going to have an increase in CPU utilization. And we'll talk more about this in detail, but if it gets really bad and there's no more CPU left, then we're going to have the spillover. And that spillover, we're going to see that through Oracle's wait interface, and we're going to see latch or mutex wait events like we see right here, this cache buffer change. And that's something that no DBA ever wants to see unless you're just a glutton for punishment or a justification for your job. But so I'm going to talk about how do we know when there's an issue, what's going on, what leads up to that, how do we begin to actually just analyze the situation, and then how can we kind of build a story so other people can understand what we already know about the situation. That's a tall order to do in 50 minutes right here, so I'm going to do as much as I can. And if you can make it to Kscope, I'm going to have I can go a lot faster when I'm in a situation like that. So, and you can always ask me questions there as well too. Okay, so that's what we're going to be focusing on. So I want to do a real quick intro on myself. My name is Craig Schalahammer, longtime Oracle DBA, and my focus is Oracle database performance. And I also do performance engineering, capacity planning, predictive analysis, that kind of stuff. I do a lot of little performance research projects, and I post those on my blog. So if you're the kind of person who wants actual numbers about what happens if we do this or how does this work, then my blog is actually a pretty good resource for you. I don't blog oh, it's sunny outside, I feel so good today. That's not what I blog about. I'm author of a couple books. In fact, what I'm going to talk about today is, I think it's like an entire chapter. It's called Oracle Serialization Control, and that's in my firefighting book. That's the book on the right there. And you can get that on Amazon, but you can save money if you just go to the OraPub website and order it from me. And I personally, prepare all the PDF orders too. So, all right. Do a lot of conference speaking, teaching, and mentoring of Oracle DBAs. I'm an Oracle ACE director, which is pretty cool. I get to go on the OTN tour sometimes. And I'm also the track manager for the IOUG conference, which was just this past April, which is one of my favorite conferences because I've been going there for years and years. So OraPub is a company that works with DBAs who want to take their Oracle performance tuning skills like to the next level. And there's a number of ways, number of resources that I help people do that. One is people can just download gobs of stuff off my website. I got tools of all kinds, all my presentations, all my public webinars that I do. I actually record these things also, and those are on my website. But for people that are like, there's a time in your life where you just want to make a decision, like I really want to specialize in something. If you want to specialize in Oracle performance optimization, then I have a membership program, kind of like a gym membership that people sign up for, and it's a monthly kind of thing. And I got special training just for the members, and I do webinars twice a month, stuff like that. So if that's something you're interested in, go to the website, check it out. Okay. I also do LVCs, full-on online training, and those are really cool. How I do them in 2-hour chunks, usually with the day in between. So I give you homework to do, and we discuss it. And so it spreads it out over a long period of time. And so anyways, if you're interested in that, it's a great option because you don't have to travel anywhere. So, all right. So the illusion. All right. The illusion is real, okay? And there's a reason, because here's a little visualization I did. I'm hoping this shows up and you can actually see this. But this is just a model of Oracle memory structures. And the whole point of this is a radically scaled down version, is that it's not just linear linked list. It's super, super complicated. And imagine hundreds or thousands of Oracle processes trying to access these memory structures and trying to make changes to those. Okay, it's a really serious thing. And if that's not controlled well, then we're going to have massive, massive performance issues. And so I think one of the keys to understanding this is to really believe that serialization is death when it comes to really computing performance. I mean, if we were constrained serially from the very core of, let's say, like an operating system, we could only have one process on one core on one thread at a time, period. But through efforts of parallelization, probably like trillions of dollars of research, parallelization, we can go nuts with parallelization. And that's great, right? That's great. The problem is, though, or the challenge is, when it comes to Oracle, all the effort of like all this parallelization kind of just funnels down to one little stream, right? And that stream is when one process needs to change one little piece of an Oracle memory structure. And only one process at a time can do that. Only one at a time. So Oracle's got to control that. So what I'm going to talk about is, well, when does that happen? Why does it happen? How do we know there's a problem when that's happening? And then how to, what's the next step to analyze that? Okay. So it's important to know where this fits into the whole Oracle paradigm of controlling access, because there's a lot more than just controlling access to linked lists. At a higher level, there's like your table locks and your row locks. That's like a relational structure issue, okay, or control, and that's done through locks. And if there's an issue with locking, if people are waiting like too long to, let's say, get access to a row, it's locked, two people want to write or change the row at the same time, then we're going to see that through Oracle's wait interface as an in-queue wait. And in-queues are very organized, right? That's because there's like debits and credits and financial stuff involved, so it must be very organized. So it's like a process in queues enters the queue and it waits. Very organized, very mature, extremely boring, right? Because we're talking like money at this point. But as we go deeper into memory structures, it's a whole different thing. It kind of opens up, and at a kind of a higher level, there's issues, there's control requirements related to individual, like just single chunks of memory, like a block that's being buffered in the buffer cache, or a SQL statement that's represented as a cursor within the library cache. Okay, those are how Oracle controls those primarily is what's called pinning. Like I pin the cursor, I pin the buffer. And what that protects is that piece of memory from being deallocated. And that's totally different than like a lock, like a table lock or a level lock. It's at a higher level, like buffer perspective. But even deeper than that though, like even deeper, we have like linked lists. And that's where what I'm going to talk about fits right in there. We have linked lists. So if you just picture linked list, that's what we're going to be talking about. And that is kind of below the whole concept of locking a table or a row. Those are transaction controls. We're going to talk below like the whole pinning of a chunk of memory. Okay, that was Katrina that walked by, business partner and wife. And so we're talking at these linked lists. So that's kind of how this fits in. And when we learn about these linked lists, usually, we simplify like a tremendous amount. And so we learn about these structures as linear linked lists. And yeah, that's true. But the thing though is that like this node of memory I'm circling right here, that node is on this linked list, what I'm calling a cache buffer chain. But this is important. This node, this chunk of memory is also on this other list down here. This is one of the LRUs. So we have the same node of memory that's on a cache buffer chain list, and it's also on an LRU. So it's like we have this one piece of memory that's on one list here, and it's also on another list. In fact, it's probably on other lists as well. And so this concept of a linear linked list, it's nice so we can learn about like the purposes of the list, but in reality, they're like super cool. I mean, they're like crazy, 3D, colorful structures. And here's just some examples. And you can download the tool off my website to create these things. You can rotate them in 3D and zoom in. It's crazy. But and these are actually really scaled down. Like this is a picture of Oracle's library cache. Again, library cache, right? And so like in this picture, in like you see where everything kind of converges on two spots here. I'm representing tables that are referenced in multiple Oracle SQL statements. And there's a lot of people that want to access these things. And so all these memory, these little pieces of memory here, we got to control these things. All right. So everybody good so far? Everybody all right? Give me a chat that, yeah, everything's good. Then I know I can continue on here. Uh-oh, no chats. You guys at your keyboard? Can anybody hear me? Yeah. Oh, this doesn't scroll down. Sorry about that, guys. Oh, okay, so let me see if I have any questions. Thank you, presenter. That's what's showing me. Good. All right, excellent. All right. Oh, now I recognize a bunch of names too. Oh, fantastic. All right. Okay. So yeah, I'm gonna have to keep scrolling down on my question box because I don't see what what's coming in. All right. So okay, so that's kind of the whole intro to the thing. This is, and then the need for serialization control. Okay, this is one of the core slides to the entire talk today. Now you see it's a little kind of pixelated here, but what we're seeing here is somebody has a baton like in a track relay race, and they're passing that to another person, okay? The concept is, it's kind of like a token concept, and whoever has the baton has access, like full control of the underlying memory structure. Okay. Now, for simplification, we're not going to differentiate between shared access and exclusive access. Okay. Just think of it like exclusive. It makes things much simpler at this level. Okay. So what's happening here is the guy on the right here, he has the baton. So he has access now. He has control to change whatever, would change the memory structure that's related to this control structure related to this baton. And he's passing it to another person. And when this person gets a hold of the baton, now they have access. Now, that sounds great, but what if a bunch of people have their hands out waiting to get that baton? Aha, that's when we have potential contention. And that's what can slow things down. And so that's what we're going to talk about in a little more detail. But the concept of like having, I wish I had something like the concept of having a control structure, that is fundamental to understanding this. Think of it like a token. If you get the token concept, you get this. That's like the first thing you got to understand. All right. Now, just to kind of put this in a little more realistic, let's say there's, let's say I'm an Oracle foreground process. All right, and I'm running code, Oracle kernel code that's in module A, and the developer knows that when I run this code right here, that I'm going to need to access this memory structure 1. Okay, and so they know that, but the developer also better know that before I can actually start messing with memory structure 1, I have to get the control structure. I have to acquire the control structure. And this is called Control Structure 101 in my diagram. So I will acquire the control structure. Once I've got it, it's in my control, now I can access memory structure 1. Okay, if you're thinking, that's like so simple, Craig, I'm like, yeah, exactly. It is simple, and it better be fast too, right? That's one reason why it's so simple. So, but here's a more interesting situation, okay? Here you can see this memory structure 411 is the control access structure, right? The baton to access memory structure 3 right here, this linked list. But in this case, the process that's run in module Z, they're the ones who have acquired memory structure 411. That's why I drew this as a solid line. But the cool thing here is that there's 2 other processes that are running different modules, module B and module X, and they also want to mess with memory structure 3, but they can't because there's one control structure. And somebody else already has that. So what they do is they are both trying to acquire this memory structure 411. And once they do, then they can access the memory structure. But until they acquire it, it's hands off. It's hands off. Because if they somehow cheat and get another phantom control structure and start messing with memory structure 3, bang, Aura 600 or core dumps and all sorts of really bad stuff, corruption, whatever. Okay, so that's another way of actually looking at this. All right, so that's really important to get that. Okay, so this is like the most important slide of the entire, because it's the basis for a lot of stuff that we're going to talk about here. Okay, all right. Let's see. Will the recording be available? Yes, it's going to be on the ODTUG website, and I actually record these as well too. So, yeah, you'll be able to listen and see them. Good question though. Okay, so let's talk about this. It's extremely simple, but it's kind of vague too, and that's because Oracle continues to change the algorithm, the details of the algorithm here. So if anybody tells you Oracle doesn't innovate, they're not creating, they're not updating, changing, making things better, they're an idiot. I mean, I don't know how else to say that because they just don't know. Okay, it's pretty arrogant to say that because Oracle continues to change stuff. All right, so let's say that I need to get this control structure. How do I do that? Okay, so first of all, a control structure, trying to acquire that, okay, I lied a little bit. It's actually a memory address. And what I'm trying to do when I acquire this, okay, is I'm actually trying to get my Oracle session ID embedded, or I put that in a memory address. I put my session ID in a memory address. And when it's in there at that time, bang, I have exclusive control of the control structure. So what I'm doing here, first I say, did I acquire the latch of the mutex? So it's like I make one attempt to get it. And let's say I do get it. I'm like, woohoo, I got it. Then okay, now I can access the memory structure. But if life was only that simple, right? It's not that simple in Oracle. So it's highly likely, especially if there's multiple, sessions involved here, which there probably is. That's why people license Oracle. You don't license Oracle because you have a couple users, right? You license Oracle because it's a very high concurrency environment typically. All right, that's one of the main reasons people buy Oracle. So let's say I make a swipe, I try and get the latch mutex, and I don't get it. Okay, then I ask myself, essentially, is this just futile? Is this working? And so I'm going to make up to 2,000 attempts to try and get a latch, and up to 255 attempts to try and get a mutex. Now, just because I don't want to really get into mutexes or the details of these yet, basically both of these they're just different ways to, I'll just say, different memory structures are protected differently. Some are protected by a mutex, some are protected by a latch, but it's the same general idea. Okay, so if I try and make a swipe, did I get the latch? No, I didn't. Is this futile? Like, have I made more than 2,000 attempts? No, I haven't. Try again. So I immediately go, give me the latch. Did I get it? No. Give me the latch. Do I get it? No. Give me the latch. And I just repeat this over and over and over up to 2,000 times. Yeah. And this is a tight loop. So it's just like, gimme, 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 kind of a thing. And I keep looping here until I hit the 2,000. And it's like, this is not working. This is like futile. This is ridiculous. This is embarrassing, And so I'm going to back off. Okay, now the back off has changed definitely over the years of Oracle, but essentially is I stop, I pause for a certain amount of time, or based on other algorithms, I back off. And so I stop doing what's called the spinning. Spinning is the repeated, give me the latch, just the repeated attempts. That's the spinning on the latch, if you've heard that. If I don't get it 2,000 times, I back off. And then I wake back up and I do it all over again. Gimme, 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 gimme. Back off. Gimme, 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 gimme. Back off. Gimme, 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 gimme. Got it. Yes, now I can access the memory structure. So this whole process of the spinning and the sleeping, or the back off, this is all part of just trying to acquire the latch. And so you think about it. I haven't even done any work, right? I'm not, from a user perspective, I'm just trying to get permission to actually do some work. So that's why when a process cannot acquire the control structure very quickly and with minimal amounts of resources, it sucks, man. Performance just goes like, it's like crash and burn, massive explosion. It's really bad. And it can actually happen pretty quick if it starts to really set in. Okay, so this back off, we're going to talk more about the back off and then what's in, how does that work and all that. But this is the general concept, and it's called the spinning and the sleeping. Okay, now that's really simple, and you might be thinking, well, Craig, like, what's the big deal, man? I mean, come on, it's pretty straightforward, right? Well, think about it like this. Think about it. There's like a lot of people, a lot of processes involved. Okay. And they all need to get the control structure. I mean, this is the reality with Oracle, right? There can be hundreds or there can be thousands, okay? But all it takes is more than one to cause the potential issue, right? So, and I want to back up a second. When I talked about in-queues with locks, like row level locks, table level locks, and a process enters the queue and then they just kind of wait very quietly, very mature. It's boring, right? Latches and mutexes, Wild West, man. It's crazy. There is no in-queue. There is no like boring, mature. It's just like, gimme, 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 back off. Gimme, 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 back off. And everybody's doing the same thing at the same time, right? Multiple cores, they're going to have multiple processes doing all this. So you picture a big room full of people and they're all saying, gimme, 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 back off. Gimme, 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 back up. And you'll hear this like, gimme, 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 gimme. You'll hear this, and then all of a sudden, and nobody knows when it's going to happen. It's like the control structure is released. And it's like this goes poof, up in the air, and people see it, right? Picture this, and they're like, there it is, and they're like, everybody races toward it. And like one person's like, oh, they get, and they're like, whoa, I got it, woohoo. And somebody else is like, oh, shoot, in slow motion kind of a thing, right? So, they see one person's like, I got it. And somebody else is like, oh, shoot, everybody else, they're still doing this kind of thing and then the back off and this kind of thing, right? And so there's a huge, massive difference between locks, that is in queues, and latches and mutexes. I mean, it's just massive. Just that alone tells us that it is a huge difference between the two. Okay, and this is at a much lower level, so it's random. It's like a probability kind of a thing, right? So yeah, the first person that asked, I guess, could be the last person that asked. Thankfully, I've never, that I know of, experienced that before, right? And you might say, well, but what does that happen? What if it takes a long time and I would have been quicker? Well, the problem with in queues is that there has to be another kind of process, another way to, what happens if two people want to enter the queue at the same time? How do you handle that when you have multiple cores? See, with latching and mutexes, that takes care of itself. And without getting into the detail, it's like when you, in order to acquire like I'm not even going to go down that path. Anyways, so this is much lower level access than a lock. Okay, all right. So that's important to understand this. Now, that's how it kind of works. But if we're responsible for figuring out the mess, when we see, our top waving is a mutex or like cursor pin S or latch cache buffer chain, something like that, we need to know more than just, the whole spinning and sleeping thing, which is amazing if you really get that, right? We need to understand how we need to, we need to relate. Wait, hold on a second. I got an email or a text from a buddy of mine. I lost my train of thought here. All right. We need to understand how this relates to Oracle's time model, because primarily that is how we diagnose and analyze Oracle performance. So we need to understand, this whole spinning and the sleeping, that this acquisition process, how is that recorded in Oracle's time model? Okay, so this is where this would be a good poll question. So I want to ask you guys a question. Okay, all right. So this spinning process, okay, is spinning on a latch consuming CPU or wait time, or actually is it consuming? I'm going to say, is it A? Is it wait time? Actually, consuming is not the right word. Is it wait time? B, CPU time? Or both? What do you think? When we're spinning on a latch, this is the gimme. Is that wait time, CPU time, or both? So put your answers in here. Let's see what we get. Okay, I see a CPU, wait, both. A, that's the wait time. We got wait time. What else? Here we go. We got a both. We've got CPU time. This is awesome. We got both. Oh, we got both. Oh, this is great. You guys are really fortunate that I'm doing this webinar today because there's a lot of not correct answer right here. All right, excellent. Okay, the correct answer is when we are spinning. Hey, thank you all for answering. That makes it so much more exciting for me. Yeah. When we're spinning, it's CPU. Okay, it's CPU. Okay, so the back off, that's primarily going to be the wait time right here. Okay, and I'm just going to say the wait time. And so if I just kind of alter this question a little bit, right, is the waiting, or I'll just say the back off. Okay, that is the wait time. Okay, so there's no both, although when you get down to it at a lower level, there could actually be a little CPU consumption, okay, especially with more recent versions of Oracle. Okay, so let's see how this relates to the time model then. If you believe this, okay, and I'm telling you the truth here, okay, I'm not messing with you guys, okay. So if we believe this is true here, I'm trying, hold on a second, I'm moving some windows around here. Here we go. All right. So if we look at your typical AWR report, in fact, let's just look at this AWR report right here. Okay, actual AWR report kind of thing right here. Okay, so if we go down here and we look at the foreground events right here, the DB CPU, that's the CPU consumption for an Oracle foreground process. Okay, so what does that mean here? That means DB CPU consists in part of the spinning, okay, of spinning. Okay, that's where it goes. Because, and think about it, it makes so much sense. Because when I'm saying, give me, right, I'm like moving my arms here, right? This takes energy, right? And if this is a program, this is like a for loop or a while loop. This is actually, I'm running Oracle kernel code, and that takes CPU resources. It just makes sense, right? If you think about it that way. Because this is repeated attempts. I'm burning CPU here, okay? And remember, Oracle processes want to burn CPU. That's how they get their work done. And if a process cannot burn CPU, there's got to be a really, really, really good reason for it. And the wait events give us clues about why the process is unable to burn CPU. Okay, so when we're spinning and we're not able to acquire the latch or the mutex, that's when we're going to back off and we're going to sleep. And so the sleeping part, okay, I'm going to say the wait time is the back off, okay, is the back off time, okay. And so in this example here, in this AWR report, the DB CPU time, part of this is going to be the spinning, okay. And if you think about it, what's happened, let's say, again, this is the capacity of the CPU subsystem. And as there's more and more and more spinning, the CPU consumption is going to go up, but the spinning component of that is also going to go up. And then when we actually start running out of CPU, this is generally speaking, then once we start running out of CPU, Oracle's saying, listen, this is ridiculous. It's not working. We're like out of CPU. And then we have the spillover, and the spillover is the wait time. And lucky for us, Oracle says, Craig, the spillover is happening because people are unable to quickly acquire these cache buffer chain latches right here. Now, and it didn't work spinning. For whatever reason, we couldn't quickly acquire the latch spinning. And so things got so intense, right, that the processes actually had to start backing off. And when they back off, there's got to be a reason for the back off. Anytime Oracle cannot burn CPU and it wants to, right, there's a reason for that. Okay, and that reason is like encoded within the wait event. Okay, so that's in this example the reason why we're unable, or the reason. What am I trying to say here? We're trying to acquire a cache buffer chain latch, and we were unable to do it quickly by burning CPU, and so we had to back off. Okay, so really the acquisition time is the wait time plus part of the DB CPU. Okay, the question now is, well, how much of this is spinning? Oracle does not tell us that. Oracle doesn't instrument CPU consumption. It does instrument wait time, and that's what all this is about. Okay. In fact, this is an important point here as well. Okay. Okay. So Oracle does instrument the wait time. Okay. Oracle does not instrument CPU consumption. Okay, an example that would be like DB CPU. An example of the wait time in this case would be like latch. I'm going to put just CBC for cache buffer chain. Okay, all right. So how do we conclude that Oracle foreground process has acquired a latch or mutex? When is both the same? Okay, so how do we know that Oracle foreground process has acquired it? Well, the only way you're going to know, if it's actually, if a particular process has it, you're going to have to go from an OS debugging standpoint, so you can actually watch the actual Oracle kernel code going. But if things are working well, that's not an issue. you won't even see this wait event up here, right? There'll be like another top wait event, okay? Because remember, before we see the wait event, there always is some spinning, right? But that's like, it's going to be like a low percentage of your CPU consumption. It's only when it starts getting intense, that's when we see the spillover. So the moment you see the spillover, that's the wait event here, then we know that, you know what, there's got to be, I wish I had a good number here, but I just want to say significant percentage of this is going to be related to spinning. Now, the other thing is that once you actually get the latch, this is all about protecting memory structures. So once you get the control structures, you're going to burn even more CPU to actually do the work, like related to like the buffer cache, for example, right? So this is like a really CPU intense situation, right? I'm trying to acquire latch because I need to do some work in Oracle's cache. So it's like CPU and more CPU. And that's why, and just to give you an example, look at the host CPU utilization here, right? This is the user time and the system time. Add that two together, that's about 99.9% CPU utilization. We have a massive CPU bottleneck right here, okay? All right. Anyway, and that's very typical when you get latching issues, okay? So when does both the same work of acquiring, when does the same work of acquiring, I don't understand that question. So can you, yes, ask me that question again, okay? Or phrased a different way here. All right, so let's continue on right here. All right, I'm going to skip some slides here because we've actually talked about these. And understanding, one of the key things also is that remember acquiring the latch, the mutex. This is a probabilistic kind of a random thing, right? Everybody's just saying gimme, 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 gimme. So there's no ordering. The ordering is locking. We're not locking here. Okay. All right. Okay, let's talk about latching in more detail, and then we're going to talk about mutexes in more detail. Okay. All right. Hey, by the way, let me just back up a second because I want to focus on this. Okay. So the way that I want to make this a little more practical because obviously at this point we know that we have a latching issue. And we know the actual name of the latch. And this is important. If you must know the name of the latch, because each latch is related to a specific memory structure within Oracle. So it has to do with a particular part of Oracle's architecture. So once we know the latch, then you got to figure out what the heck is a cache buffer chain and what can cause contention trying to acquire a cache buffer chain. Answering that question gives you a list of solutions. So for example, okay, this is like the application part here, okay? Not just the how does Oracle work, but how do you actually, do this? How do you actually use this? Okay, so the way I do this is I look at this from like 3 different circles. And those of you that are like members and you follow my stuff here, I'm going to call this the OraPub 3-circle approach or method operating system. Because what I'm going to do, I'm going to come up with solutions from both an very Oracle-focused perspective to a very operating system-focused perspective and a very application or like SQL or process perspective. Let me give you an example. So for Oracle, I know for Oracle, so I need to do some additional analysis related to cache buffer chains. I need to know whether there's like one specific cache buffer chain that's just getting the crud beat out of it, or if there's a lot of different chains that are getting the crud beat out of it. And we can tell that by looking at the $V views and doing some additional analysis. And I need to know the answer to that because the answer to that tells me how I can actually, change instance parameters, low level, I can actually change the path of Oracle execution code by messing with these instance parameters, all right. So Oracle, I got to do additional cache buffer chain analysis, blah, blah, blah. So I need to do some more work, okay? And that information is not contained within an AWR report. I'm going to have to go outside of an AWR report. From an operating system perspective, well, I'm out of the CPU, right? This is why it's so important to be able to find the bottleneck at the operating system. Is it CPU, IO, memory, or network? You got to be able to figure that out. If you can't figure that out, you're going to get, I got to think of a kind word. You will hit a wall in your career. How about that? Okay. Operating system. We need more CPU power. okay? So that means faster and or more cores, not threads, cores, okay? Now you might say, well, yeah, but that might not be the real answer to the problem. You know, you're probably right, but it would sure let more throughput. It would allow more throughput to flow through Oracle. And so while you're actually figuring out the real problem, it would be nice to get more CPU power. You might say, well, Craig, we can't do that because, you know, we don't have the money to buy more CPUs. Well, the more virtualized, the more cloud-like, and the more VM-like our systems become, the easier it is to get more CPU power. Take it from another virtual machine who doesn't really need it at this time. Okay, so this actually becomes an easier option now than it ever used to be. Okay, on the application side, now once you understand what this cache buffer chain beast is, okay, then we say, okay, what kind of SQL would cause this kind of stress? Okay, now this is like advanced Oracle thinking, right? Because you've got to understand how Oracle works and how it relates to the wait event here. So you got to understand this whole cache buffer chain process, right? Which we're not going to get into, okay? But I'll tell you a little bit about it in just a little bit. But so you got to understand that, and then you think, okay, what kind of SQL is this going to be? Like physical reading type SQL that's doing a lot of block access to the IO subsystem, or is it going to be more like CPU intensive type SQL, or SQL that gets executed a lot? Okay, well, this is going to be more CPU focused SQL. SQL that's doing a lot of buffer gets. This is buffer cache stuff, okay, which is buffer get SQL, that kind of thing. And sometimes it's SQL that's executed a lot, frequently. It could be something like, I'll just say a lot. I don't know, real scientific, I know. Okay, but really, these are the main. This is the big one right here. You say, well, why is that? Why is this the big one right here? Because look at how much time is associated with that, right? I'm not going to get into this, but if you kind of divide up all the time into categories like CPU, and then you take the wait time and you kind of break that up into different categories, and you look for like the big chunks or big piles of time, those are our opportunity areas. And clearly, we have a big opportunity area to reduce time. It's like it's a big target, right, is CPU. And the next big target is going to be this latch cache buffer chain wait time right here, okay? And so there must be, right, remember this, there must be SQL running, executing, that's actually causing this. There has to be SQL, right? This doesn't happen. There must be SQL. So there absolutely has to be high consuming SQL statements. There's going to be like a top SQL statement for sure, 100%, because if there wasn't, we wouldn't see this like profile, this thumbprint of the timing right here. And so we know there's going to be some CPU right here, or high CPU consuming SQL statements. Okay, all right. Anyways, all right. So I wanted to kind of get this a little more real before we kind of go into the next area right here. All right, you guys still with me? Everybody still on board? There we go. Yep, with you. Yes, still good. All right, Kaylee's still good. That's good. Kaylee, if you're not on board, I got some serious problems here. All right. Good. All right, excellent. Okay, so let's go to the next slide here. Oracle Latch Specifics. This is going to allow us in the last like 15 minutes here to go into latches and mutexes a little bit more detail. Okay, so this is the latch way. Okay, and there's another slide that says the mutex way. Okay, now I know this is extremely cryptic right here. So what what this is a diagram of is Oracle's library cache. The library cache is like picture it like a library with books, complete with a card catalog. Okay, but instead of an actual library with books, this is a library full of Oracle SQL statements and functions and procedures and definitions of tables and views and sequences. That's what this library is full of. So when we go into the library and we want to know, hey, is the book currently in the library, or is this SQL statement already in Oracle's library cache? We've got to go through this process to answer that question. We need to access the library cache. Okay, so what I'm going to do is I'm going to take, let's say we're looking for a SQL statement. I'm going to take this SQL statement, my foreground process, right? I'm burning CPU. I take the SQL statement, I hash it, Okay, I'm not going to get into that. Okay, you guys, a lot of you guys are developers, so you know what I mean by hashing. I'm going to hash this statement, and it's going to hash me to a bucket, a hash bucket. And then if my SQL statement is like anywhere in the entire library cache, it must be associated with this bucket. If it's not associated with this bucket, I know it's not anywhere in the library cache, and then I have to do what's called hard parse. I have to get this SQL statement into the library cache. It's like going to the librarian and saying, listen, I need a book and you guys don't have it. I know you don't have it. What do I have to do to get the book in there? And she looks at you like, oh, kid, you are such a hassle for my day here. Fill out this form. It takes a lot longer. There's a lot more pain involved, and that's like a hard parse. It's painful. You don't want to have to do it, but sometimes you got to do it. You got to get the book. You got to get the statement in the library. Okay. Now, before I can actually answer the question, is the book in the library? I need to get control. Say, well, why? Because this is an Oracle memory structure right here. This is not related to a table. This is not about pinning something, right? Well, it can be pinning something because I can pin the cursor right here, okay? But at this point right here, I actually need to potentially modify this. I just don't, it's not about making sure it's not deallocated. That's more of a pin. All right. Sorry, I'm throwing a lot of words at you if you're not used to this kind of stuff. Hey, Vaclav, awesome. Glad you're here, man. Just saw you. All right. So what I'm going to do, though, before I can actually go check this out over here, this part of the library, I need to acquire the control structure. Okay. Now, hopefully that makes sense to you. Now, this is absolutely key. Because this will differentiate why do we have mutexes in addition to latches. Okay. Pay attention. This is the answer. Because what if I need to get to the bucket here at the top and you need to get to the bucket at the bottom, but there's only one control structure, latch ABC123, right? We're going to contend for the same structure, but really we need to get to different memory structures. So we're not going to be walking over each other, even if we wanted to change what we want to change. The problem is there's only one latch related, right, to like two different buckets, two different chains right here. That's a problem. There's a special word for that, really technical. You guys ready for a technical word here? Anybody know what that word is? The words? There's two pieces to it. You know what that is? I'll give you 5 seconds. 1, 2, 3, 4, 5. Okay. False contention. Big word, right? Because let's say that I actually have the latch. You're gonna have to like keep contending for this latch, so you can actually then go down like a different hash chain right here. False contention, right? That's false contention. Oh, somebody got it, Kaylee. All right. You didn't type that in after I said it, right? All right. So that's called false contention. With mutexes, the control structure. Get this. I'm going to skip some stuff here. I'm looking at my little cheat sheet here. Here we go. Boom, here we go. The mutexes can be at the individual memory little piece at the memory node level. Now, I honestly don't know if Oracle has it at this low level right here. I do see when I do a library cache dump, I do see the word mutex related to, I think it's with the parent cursor. Pretty sure about that. I'm not going to check it out. I think I have it in the slide deck though. So if you download that, oh, by the way, you can download this off my website. Okay, I did this presentation at the IOUG conference, and look for that one. It's at the top. This is the exact, and you can see all the slides because I'm only talking about a few of them. Okay, so let's get back to mutex. The mutexes, what's so cool about mutexes is that when Oracle like creates this chain, or when it says, hey, I need to create this cursor, this parent cursor right here, it's called, the control structure is actually like, just like, it comes to life within the memory structure, right? It's not like it's this whole separate thing. It's actually embedded in the memory structure. So think about this. So instead of the control structure being out here, and we have this false contention possibility, the control structure is actually within the memory structure. So what the development code does, it says like create this memory structure and like boom, you get the control structure. When it comes time to deallocate this, boom, it's gone. So is the control structure. It's very cool. In fact, the Mutex code, a lot of the Mutex code is already in the C programming language. So Oracle kind of rides on top of the C functions that are already in the programming language. It's not like that with Mutexes. If I go back to Mutexes, Oracle has to write all of this code. Oracle has to write all of this code. Okay, with Mutexes, Oracle is involved in this, but it's through parameters. Okay, by the way, the Mutexes go through the same spinning and sleeping. It's the same concept with Mutexes. But the big advantage, though, with Mutexes is we have the control structure is embedded within the memory structure. Okay, so I jumped ahead and we started talking about Mutexes. All right, let's see. Okay, I want to show you just one other couple things. That you know there is always a need to have more than one memory structure for a larger, let's say, like the cache buffer chains. By the way, the cache buffer chains are all about answering the question, is the block I need to access already in the buffer cache? Okay, you think about that. If a process is executing a SQL statement, it needs to access a block. It needs to know where it is, right? Because if it's not in the buffer cache, then it's going to have to go get it from disk to bring it into the buffer cache. Well, how does it answer that question? It accesses the cache buffer chains. And if the block is not in the buffer cache, it will not be in the cache buffer chain structure. It's actually that straightforward. And so if you have a lot of processes that need to answer the question, hey, is this block in the buffer cache? Is this block in the buffer? If this block is in the buffer cache, all the spinning is going on, that kind of stuff. And you get too many people asking that at the same time, especially if they're asking for the same block. All right, they're asking the same question about the same block. You know, one of these latches is going to get really, really hot. Okay, it's going to be difficult to get it. All right, so clearly, one control structure is just a disaster waiting to happen. I mean, come on, right? That's like giving one toy to like 50 kids. In fact, let's just say one toy to like 2 kids, right? They're going to be fighting over that thing, right? They're trying to get control of the toy. So what do, right? If you're a compliant, setting your child up for disaster later on in life, you buy them each a toy. So there's no conflict avoidance necessary. And this is what we've done here. We now have 3 latches instead of 1, so it's easier to get the latch, right? We're less likely to have to spin so much. We're less likely to have to back off. So DB CPU drops, the wait time drops, throughput increases, users are happy, blah, 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 blah. Okay, so we want to be able to have potentially more latches and more. These are called buckets or chains, and there are instance parameters to control all of this stuff. Okay. All right. You can do the same thing with LRUs, Oracle's least recently used. Yeah, list. I don't know how to mine thing went. Anyways. Okay, by the way, just so you know, there are thousands and thousands of these latches. This is just cache buffer chains right here. There are latches for like redo, latches for what are some of the other ones? I don't know. There's hundreds of different types of latches in Oracle, and you can have thousands of each one of these things. So there's a lot of these. Okay, there's a lot of these. Oracle's a busy system. Okay, one of the last things I want to show you. Remember that sleep part, that sleep thing? This is kind of a little more advanced here. Okay, how does Oracle do that? How does Oracle cause the process to back off? Okay, traditionally, the way that it does this, and it still does this to a certain extent, is it basically sleeps. It tells the process, or the process actually puts itself to sleep for a fixed period of time. By the way, years ago, there was like an exponential back off. So the first sleep would be like 10 milliseconds. Wake up, spin, 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 didn't get it. Now we're talking 20 milliseconds. Wake up, spin, 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 spin. Now 40 milliseconds. And this would just keep progressing to like a max of 2 seconds. It's not like that now. If you look at these, this is actually the sleep time. that Oracle is telling, or the foreground process. This is what I'm doing. I am doing an S trace, the system call trace on Linux for a specific process ID. It's this process right here, and that's an Oracle foreground process right there. And there is massive cache buffer chain latch contention when I'm doing this. So I'm tracing this process at the OS level. And this select call, this is an unfortunate word for us because this is not select star from dual, right? It's not a SQL statement. It's actually a C function call. There's actually a Perl function also called select. Just do a man page on select and you can read all about it. Oracle is using this to do the sleep. Now it's a fixed time, and this is actually just over 10 milliseconds right here. And so the process goes to sleep, uninterruptible sleep, and then when it kind of times out, that's what the timeout's for, process continues and it starts spinning again, backs off 10 milliseconds, wait time, right? Cache buffer chain wait time, wakes up, spins some more, right? And that's what we're seeing right here. So that's how Oracle implements that. Now, Oracle in more recent versions, it uses semaphores. So here you can see some semaphore operations. What the semaphore operations allow is it allows us to get out of this situation. Okay, we're almost out of time here. So this is one of the last things I'm going to talk about. Is let's say I've been put to sleep, or I put myself to sleep in that select call, right? But what happens if the CPU becomes available, or the latch becomes available while I'm sleeping? Like, I don't know about it. And so, but now when I wake up and I start spinning, now somebody else already has it. Shoot, and now I might have to sleep again. See, the problem is I missed the opportunity because I was sleeping. It's like if you were a kid and you slept in on Saturday mornings to watch you slept in on Saturday mornings, you missed watching Saturday morning cartoons. So yeah, I didn't get to watch Bugs Bunny today because I was sleeping. Yeah, sorry, man. What you needed was a parent or somebody to come tap you on the shoulder in bed and say, Craig, wake up, man. Bugs Bunny, Yosemite Sam, they are on TV right now. You're like, whoa, I better get up. That's what the semaphore allows us to do. We get woken up, so now we can actually, acquire the latch. So what Oracle does now with Mutex is it does a combination of this back off, fixed period of time, with the back off with semaphore, so you can be woken up. Very cool, very cool. And there's reasons which we're not going to get into, don't have time, of why Oracle is actually doing that. Okay, all right, so we're kind of at the end right here. So what have we done today? And I'm going to tell you what you need to do next if you want to get serious about this thing, man. Okay, all right, so if you have any questions, go ahead and start typing those in, okay? And I will stay on after we officially, finish, okay? So let me summarize here, okay? You guys should know the general, and this is the Latch Mutex LM. You should know the algorithm. What's the algorithm? Spin, sleep, spin, sleep. That's the algorithm right there, okay? And you should know the time related. Spinning is CPU consumption. The back off, the wait time, we are not burning CPU. There's not an overlap right there. Okay, there potentially could be a little CPU and wait time, but just don't go there, or it's just don't go there. All right. How do you know if we have significant contention? It's super easy. How do I know if I have latch or mutex contention? Like my top wait event says latch, or my top wait event says cursor. This is related to the library cache. I'm trying to pin a cursor in shared mode, and I am unable to do that. Okay, that's how you know. If you don't see these consuming a bunch, like a high percentage of the time, then you do not have latch contention right here. Okay, all right. This case, we do have latch contention. That's our top wait event, massive amounts of time right here. Okay, so that's how you detect if it's significant. Now you have to know what the latch is, because each latch has a specific way to deal with the situation. So you got to understand what the latch is all about and what the underlying memory structures is. Okay, but now you're ready to absorb that so you can see how it all works together. So you got to understand the underlying kernel code or the architecture of Oracle. Okay, last thing here. You need to understand, why is it being requested so long or so often? And why is it being held so long? Understanding what the process is trying to do and what kind of SQL is being run, it allows you to answer this question. And then what you do is you turn this answering this question into a solution. For example, you would say like, why is it being requested so often? Well, a lot of people are asking, are blocks in the buffer cache? And the answer turns out to be yes. So we don't have to do physical I/O. Everything's in the buffer cache. Wow, that's burning a lot of CPU. Yeah, and that's why we have this cache buffer chain latch. It makes sense. So we've answered the question, and then by answering that, we know like, well, wait a second. If I had more CPU, or I tune the top CPU SQL statement, I could reduce the time then, or I can reduce time, which allows more throughput, more work to flow through the system. Okay, you see what I'm saying? And so this is coming up then with the multiple resolution strategies. Now, this whole process this is what I talk a lot about this in my AWR classes, because this is actually, getting into how do we devise multiple solutions to the same problem. Okay, taken to the next level. I got a bunch of this stuff on my blog. Search for these keywords, right? That's my blog. Go to my website. You can do a search, download presentations. I got some tools. Buy my stuff, go to my classes, blah, blah, blah. AWR report is the closest class here, okay, for this. And if you're interested, if you really want to like work on this stuff, become an OraPub member, okay? Super inexpensive. Yeah, that's all I'll say about that, okay? Thank you guys for listening. I'll see you at the K-Scope, hopefully. And thanks for being here for this past hour and 3 minutes here, okay? All right, so we got 2 questions, so I'll answer those, and then we'll like officially cut off. And if you guys have other questions, wait, excellent. Thank you. Is that going to be Craig? I'm not God Shallowhammer, by the way. All right. Interesting. On one CPU system, there will be no latches at all. Okay. Is this one of those hypothetical things? Oracle still has latches though. Okay. It still has latches because you can still have multiple sessions even on a one system, even on a one core box. Okay, yeah, Oracle background processes, you can have multiple foreground processes. Oracle still needs a way to actually deal with these things. Okay, so the latches don't go away, but yeah, you can look at that as kind of overhead in a way. But if you got one session, you're going to spin once and boom, you probably get it. So like, it's not a big deal. So that's almost like a kind of a hypothetical type questions. Okay. Yeah. Thank you. Excellent talk. Thanks for your time. Work for Oracle. Oh, Oracle Chile. Awesome. Core technology. Yeah. When will I release my new book? Don't ask me that. It takes about a year. So yeah, I'm glad you like the firefighting book. Thanks, man. No, I don't have plans to update it, but I will eventually though. But when you see the book come out, you know that I'm reaching the end of my Oracle career. That is the it's imminent. All right. Yeah. Hey, I really appreciate that. All right. So that's it. Oh, holy cow, man. Look at all these questions. Okay. How do I tune without an AWR report? So that's probably like stats. Get a stats pack report. Okay. AWR and stats pack reports are all about looking at the ocean of activity, the entire instance of activity. If you have more of an incident, like a small number of sessions, then you need to be using Ash. Okay. If you have standard edition and you don't have Ash, do a Google search for like Ash standard edition. There are some solutions for you out there. Okay. There you go. Thank you. You guys are so welcome. So welcome. All right. Cool. It's good to see, people that I recognize here. Thanks for your time. Greetings from Colombia. Yeah, I forgot to ask the countries. If you guys are still on, hey, what countries are you guys from? We've got a bunch of people on. Type in your countries real quick. And then we're Chile. Okay. And so as we say goodbye here, type in your countries. It's pretty cool here. Chile, India, Mexico, India, Germany, US, Canada, Czech Republic. I know there's more. Here we go. India, awesome. Big country, a lot of places. USA, India, Canada, Uruguay, awesome. I'm going to do an LVC in Spanish for Paraguay. But anybody in Latin America, you speak Spanish, you can register for this thing. It's going to be awesome. It's going to be a translator. Republic of Florida. Oh, okay. I'm not going to touch that. Thanks, US, UK. Spain, Is that North Carolina? SoCal. Oh, Northern Cal. Awesome. Yeah. All right. Okay, this is it. We're about 10 minutes after. Thank you guys for participating. Italy, fantastic. All right, Italy. I want to go back to Italy so bad. But you don't know. I want to watch Valentino Rossi and Mugello in the next race, and I want to watch him race in Italy. All right, guys, that's it. Thanks for listening. If you have any questions, type those in. But for now, we're done. All right. Thank you.